function identities, let's pick up on this from yesterday. Real quick crash course. Trent, you weren't here yesterday. We took the 7-1 formula and we applied it to this mess right here. And because now we have actual like radian measures, then we can evaluate them and then we can simplify it. Then we took tangent and just rewrote it as sine over cosine of that exact same mess. And then we used formulas that we are learning along the way to simplify it. Same thing here. We rewrote the secant of this mess in terms of cosine of this mess and then applied the formula. 90 and pi over 2 are synonymous, and then we cleaned it up. And then this slide, we were deriving these formulas instead of me just saying to you, the double angle formula for sine is 2 sine cosine. We started deriving it. The way you derive it is by using the 7-1 formula. You rewrite the double angle as x plus x, and then you plug it into the formula, and then you can clean it up, and you see what you have. Thank you. I will bring it to you. Flex. Are you serious? Okay, well then I'm going to bring you something. Thank you. Then we did the cosine formula, and we found that the cosine double angle formula simplifies to cosine squared minus sine squared. And as the bell was ringing yesterday, I was saying to y'all, be careful. This is not the same thing as cosine squared plus sine squared. And you can't say it's -1. Like you can't say cosine squared plus sine squared is 1. Well, if there's a negative, then it's -1. No, not possible, because this would also need to be negative for that to happen, and it's not. So be careful there. That's a be careful moment. Okay. And now we're going to repeat the process, but with tangent. So instead of me throwing the formula on the board to you and saying, here's the formula, we're going to show you how the formula came about. We're going to recall the formula from 7-1 for tangent when you're adding two angle measures together. In 7-1, the tangent sum formula was tan u plus tan b over 1 minus tan u times tan b. That was the formula from 7-1. Now we're going to apply that to a double angle. Savota, tell me what's the thanks. Okay. I should send an email that says, anyone have candy? And then I would get a ton. Hold on. So we're doing the tangent double angle formula. So tan of some angle that's doubled. We're going to apply the formula here. So first, let me draw my little arrow. Here we go. First, we're going to take the 2x and break it apart into x plus x. You know where this is going. Now, everywhere there's a u, I'm writing x. Everywhere there's a v, I'm writing x. So it looks repetitive. It looks repetitive, and that's because it is. And now we need to clean it up. What is tan plus tan? 2tan, right? Or not 2tan? That is the question. That was lame, sorry. And then tan times tan. Tan squared. So this would be 1 minus tan squared x. So the double angle formula for tangent is really ugly. but it's 2 times tangent over 1 minus tan squared. Okay, which takes us to the next slide where we're going to start practicing the application of this. Like, when does this need to be used? So if you go to the next slide, you will see where I have copied the really nice formula box of what you just found. Everything that's highlighted up here, that's highlighted, is summarized right here in the formula box. There's a little bit extra. You'll notice that cosine of a double angle has a little bit extra here. Look up above it and you're going to see where that extra comes in. So for instance, this was what we found the cosine double angle formula to be, right? Well, because of that cosine squared and that sine squared, we can actually play around with this and create more double angle formulas because, one's not enough. If you will look at your yellow formula sheet, yes, go to the Pythagorean identities. You see the sine squared plus cosine squared equals 1. See that? Okay, go back to that day that I taught that to y'all. We learned, I say sine squared plus cosine. Okay, we learned that. And then, do you remember the day we had some arrows coming out of it? We were like, or you could do the cup game, where like if you shuffled sine squared over by subtraction, you would get that cosine squared is 1 minus sine squared. Remember that? Or if you come over here and shuffle cosine squared over by subtraction, you would end up with sine squared equals 1 minus cosine squared. That was day 1. We were just showing you that you could do the cup game thing and you could have some different formulas that would also be helpful. Those extra formulas are applied here. So if you notice, I'll use a highlighter, and you don't have to, I'm just trying to explain where these came from. If you look up here, they took cosine squared and they replaced it with 1 minus sine squared. And then they noticed, oh, well now you got minus sine squared, they're like terms, they both have the same exponent, so that would be minus 2 sine squared. So here's another identity for the cosine of a double angle in terms of just sine. And then over here they said, let's do the same thing, but with sine squared, we can replace it with 1 minus cosine squared, which would then you would notice you have a negative. You have to be careful with this one. You have a negative right there that would change the signs of everything after it. So that would be minus 1 plus cosine squared. So then you have cosine squared plus cosine squared, which is 2 cosine squared. Treat the trig function like a big giant variable. You know what I mean? It doesn't change. You're looking for like terms so you can combine them. So cosine squared plus cosine squared, it's a mouthful, is 2 cosine squared. And then copy the minus 1. So that is a second identity. So this one is right here, and then this one is right here. Okay? So that's where these extras come from. So if you want to say, like draw an arrow to say, it could be any of these 3, you do have 3 choices there. However, with the sine and tangent, you just have the 1. It's just 1. They didn't get fancy with it. And that's because there's no squares in here. Well, tangent squares in there, but there's no sine squared or cosine squared. Okay, so the explanation of where those extra ones came from is right here. If you need that explanation. Now let's dive right into a practice problem, okay? So look at example 4. Here's where we're using the new stuff. The first 3 examples, we didn't use the new stuff really. It says find an equivalent expression, which means you're not actually stating a numerical value. You're manipulating it in sine, cosine, tangent to get a different expression for sine of 3 theta. So this is the problem. Sine of 3 theta. There is one of these on your test. One. Because you can't do one. I'm not going to throw 2 at you because then you wouldn't be able to do 2 of them, right? There's only one on the test. How do you know when you're dealing with this? When you see some type of multiple in front of the angle, that's your indication that, hey, it's a double angle formula. Okay? It's not a regular angle. This is, in this case, it's a triple, which means I need to be using my double angle formula. Now, we're going to go off on, no we're not, because it's sine, there's only one way to answer this. Had that been cosine, there would be 3 possible routes to take. And that's another reason why we're doing our test on paper, because I'm going to look at your notes, follow the route you take, and make sure you do it right. Hi. Thank you. Who's that from? Miss Willis. Tell her some thanks. I didn't be like, does anybody have $1? Does anybody have cookies? Oh, okay. Had this been cosine of 3 theta, you would have the free choice of which one you want to use. Doesn't matter which one, as long as you're cleaning it up the correct way, then you'll come to the correct answer. So on the test, if it is a cosine question, because I just, would torture myself that way, I will have to check which route you went and make sure it's correct, and you'll get the credit. With it being sine or tangent, there's only one route to go, so there's only one right answer. All right, so here's how we're going to do this. We have sine of 3 theta. We want to manipulate the 3 theta. Draw my little arrow here to show I'm fixing to manipulate it. We want to manipulate it into a double angle and a single angle. So sine of 3 theta could be rewritten as sine of 2 theta plus theta. If the theta bothers you, then change it to just x. If the theta is throwing you off, change it to x. Nothing wrong with that. Do you see how I got that? That's just basic algebra. How do I get 3 theta? Well, you could add 2 plus 1. Now, the order that you write this, no, it doesn't matter. So you can write theta plus 2 theta, or you can write 2 theta plus theta. It doesn't matter which one you do. Now what we're going to do is we're going to go to your 7-1. Go to your 7-1 formula. So flip your notes backwards, or look at your yellow formula sheet, and go to the sine sum formula. The sine sum formula. The sine sum formula from 7-1, I'm going to write it right here. Sine of u plus v is what? Sine u cosine v plus. Okay. Alright, so that's our 7-1 formula. We're going to apply that here. So the order that you write the sum of the thetas will dictate the way that you plug it into the formula, but your work along the way, although it may be different than your neighbor, your final answer should be the same. Okay, so I'm going to clean this up and apply it to that formula. So everywhere there's a U, I'm putting 2 theta, and everywhere there's a V, I'm putting theta. So this is my U, this is my V. So I'm going to carefully write this out. And if you need to put the 2 theta in parentheses to draw your attention to the fact that it's a double angle, then I would suggest doing that so that you remember that that is, that's a formula there. All right, and then we've got cosine V, which is theta. Now, all that's left is finding the double angle formulas and replacing them with the expressions, the substitution, the expressions that we found, and cleaning it up. We do have a cosine double angle right there, which means when it comes to the cosine double angle substitution, you have 3 choices to take. There's no wrong choice. So that's where I'll have to just do extra work to check your work along the way. I chose cosine squared minus sine squared. I don't know why I chose that one. It's probably because it's the first one. You could have easily chosen the second or the third. All right, so let's go through. Sine of 2, I'm going to change colors so you know I'm substituting. Sine of 2 theta, the 2 theta is a double angle. You go to your double angle identities on your yellow formula sheet that you will have for the test. You find sine of 2x, and now we're going to replace it with that. So where this is right here, this block, I'm fixing to replace it with 2 sine theta cosine theta. Then I'm going to bring down this cosine theta right here. Now I have another double angle identity. I've got this block right here, cosine of 2 theta. I have the free choice of which one I want to use. I personally went with cosine squared minus sine squared. Does not matter. You can use the second one, you can use the third one. It really does not matter. Then I'm going to bring down the sine theta. Now, on the test, you would be showing your work along the way. I would see this. I would understand exactly what you substituted in so then I can check your work. You will get partial credit for getting this far, but this is not done, right? The idea was find an equivalent expression for a triple angle in terms of just sine and cosine. You're kind of calibrating it down from a triple angle to just sine and cosine. And so we've got to clean this up. So look at it very carefully. This is all multiplication, right? Terms are separated by plus and minus signs. Here's your plus sign right there. So this mess here in the front is just all being multiplied together. So what can simplify? Yeah, it'd be cosine squared right there. Did y'all see that? So it'd be 2 sine cosine squared. Now let's focus our attention with this stuff at the end. You do have sine theta hanging out on the outside of some parentheses with a binomial on the inside. I say a binomial because there's a minus sign right there, so there's actually 2 terms here. So this sine theta has got to multiply in here. It kind of feels multiplying backwards in a way because it's coming after it. If that bothers you, then just visualize the sine being right there, you know, and scratch that out and multiply it in. Okay, so I'm going to clean this up by just multiplying that sine in there. So, and I'm going to keep my order. You see how here I have a sine, cosine squared? Like that's the order of it. So over here, when I multiply sine times cosine squared, I can already see I'm going to yield a like term. So I'm going to keep it in the same order by putting the sine in the front so I don't confuse myself. You see where that, because now these are going to be like terms on my next line. See how I got that? And then now what's negative sine squared times sine? Negative sine cubed.
So if you did just sine times the cosine, why did you not do that officially?
I did, but there was already a cosine in here, so it became squared.
Yeah, but you didn't do that for sine.
This sine right here multiplies times this cosine squared. They're not like terms, so they just shove together.
Say for like the first half of the equation, if you were to distribute the cosine that's outside of it, and you distribute the cosine to the cosine squared, why not make it 2 sine cosine?
Oh, because there's no plus or minus. Like this is one term.
Okay.
This is the equivalent of 2yx times x. So it'd be 2yx squared, and then this is the equivalent of x squared times y. So you just shove them together.
So is the squared for all of it then?
No, the squared is just the trig function,
Okay.
like itself. And that's the concept here, is we're taking a triple angle and we're reducing it to where it's just an angle, and you may have a trig function squared, which is allowed, that's okay. But we no longer have this triple angle. We just have the plain old theta. And the good news is we don't go any further with it. Like, I mean, there's another line, but I'm saying we don't actually evaluate this. We don't go to the unit circle with this. None of that's involved. This is just a question of, can you take a multiple of an angle, calibrate it to a double angle and whatever's left, apply the 7-1 formula, and then apply the double angle formulas and clean it up. That's the purpose of the question. So now, if you look at it, and here's what a lot of people don't like about this question is when you see this final answer that I'm about to write, I only have one line left. You're going to think, well, that's uglier than what you started with, and I'll agree with that. But that's the purpose of the question, is taking a triple angle and reducing it down to just a single theta. All right, so this 2 sine cosine squared. Don't read the theta part because this just creates a mouthful. Focus on the trig. 2 sine cosine squared plus sine cosine squared. They are like terms because this matches right here. That matches. So it's almost like a giant, variable at the end. So this is 2 plus 1 of that mess. Okay, so that would be 3 of that mess, right? And then that crap on the end just comes down. And that is the formula. Or not formula, but that's the answer. So you might want to make a note to yourself that although that the answer looks uglier than what you started with, the goal was taking that triple theta and reducing it to single theta values. Okay? And we did that 2 ways. We changed colors. I'll go to green. We applied right here the 7-1 formula. Then we substituted, I'm going to put double theta formulas. So it was 2 parts. You applied the 7-1 formula when you just kind of stretched out 3 theta into 2 theta plus 1 theta. Then you applied the double angle formulas, and then you just cleaned it up. Okay? There's one of those on the test. Just one. Alright. Let's go to example 3. This one's one of my favorites. A lot of people tend to get this right. Very rarely do people miss this. The textbook only provides one practice example. You can see where I provided 2 more practice examples because I just wanted to make sure you did understand it. Alright, so look at it. It says, given that tan of theta is negative 3/4 and theta is in quadrant 2, find each of the following. Okay, so let's understand what it's asking. It's providing you with a given trig function.
No, it smelled. It was like
My candle burned out.
what? She blew it out.
Oh.
Yeah, it was like smelled
Gotcha.
like smoky.
Did you, oh yeah, you did. Thank
Covered
you.
it. Yep, you're welcome.
So this is saying, hey, here's a trig function, and then I'm telling you what quadrant you're in. This goes back to chapter 6. This is where you want a picture of the quadrant you're in, and you want to draw the triangle and fill in the sides that they give you, and find the missing side that you don't know. Okay, so the setup here starts out exactly like from chapter 6. What quadrant am I in? 2. So I'm going to draw quadrant 2. Remember how to draw your triangle. It always collapses to the x-axis. You don't draw it to the y-axis. That's a no-no. So it's going to come out of the origin and then collapse to the x-axis. That was better. Draw your right angle. Our theta is our angle, so that goes right there in the corner. Now you have to remember, and I think it might be on there. It's not on there. Like the basic formulas from geometry are at the very top of your page, opposite, adjacent, and hypotenuse. But it is a lot easier if you level it up to remember sine is y, cosine is x, and hypotenuse is the radius. So it says tangent of theta is negative 3/4. They're giving you 2 sides right there. You have to be intuitive enough to know what 2 sides they give you. Well, you just look at what trig function it is. If they're giving you tan, then that's y over x, right? Or opposite over adjacent. If they're giving you sine, then they're giving you y over r. If they give you cosine, then they're giving you x over r. Remember that? But again, if you forget those, they're at the top of your formula sheet from the geometry terms. Okay, so the y value is 3. The x value is 4. Here's the catch. Huh? One of them's negative. It doesn't tell you which one's negative. You have to know, oh, I'm in quadrant 2. What would be negative? The x would be negative. So you have to know where to put the negative. Okay? Now, if you're in quadrant 1, you don't have to worry about that. But if you're in any of the other quadrants, you would have to know where to put the negatives. If you're in quadrant 3, and they gave you tan, it would be positive. You would have to know when you drew quadrant 3 that they would both be negative.
So on the homework,
Yeah.
This one says tangent theta equals negative 7 over 44. But it doesn't give you the quadrant. You have to
Does it
figure
say
out
what theta is in between? Does it say theta is?
like between pi over 2 and whatnot. No, it doesn't say that. It's
If tan
yes,
is,
it does.
there you go. If tan's negative, then you know you're in either 2 or 4. But they'll specify, they'll either say what quadrant you're actually in, or you gotta know these, pi over 2, pi, 3 pi over 2, and 2 pi. Or they might say theta is in between. For instance, if I wanted quadrant 2, I would say in between pi over 2 and pi. So that's another way that they can secretly say, hey, you're in quadrant 2. But yeah, they'll always tell you what quadrant you're in. Okay, so we've drawn our triangle based on the trig function given. We've labeled the negative as needed. We need to know the hypotenuse because we're fixing to have to evaluate these trig values over here. So this is where the Pythagorean theorem comes in, although you really don't need it here. What is it? 5, it's a 3, 4, 5 triangle. You might be like, well, it's -4. It doesn't matter. It's still 3, 4, 5 because you would square the negative. So this is 5 here. But make a note to yourself, a squared plus b squared equals c squared, so that you remember if it's not a Pythagorean triple, you would have to do the Pythagorean theorem there. And find that missing side. Okay. Now, the rest of this problem, like the approach of this, we have the setup, we have the info. Now the problem itself is literally going to your formula sheet, writing the formula down, and then plugging in the fractions, the ratios based on the formula. So go to your yellow formula sheet. Remember, cosine's the only one that has 3 choices. It's the stairwell. It's so annoying. Go to your formula sheet, find the double, this is how you know where to look, the double angled formulas. And then read to me the sine one. It's 2 theta, cosine theta. Okay. So then you write it down. So you pull the formula from the formula sheet. Now you plug in the ratios. This goes all the way back to geometry. Okay, it's just leveled up and embedded within a college pre-cal problem. We're going to plug in the fractions that go here. So I'm going to bring the 2 down. I'm going to draw a big old parentheses because I'm fixing to plug fractions in for sine and cosine. Where do I get my fractions? The picture. You go to your picture. If you forget the sine and cosine formulas, they're at the top of your yellow formula sheet, but you should be familiar with them. Sine is y over r, or opposite over hypotenuse. You're good. So 3 over 5. Cosine is x over r, so what would that be? -4 over 5. The negative matters here. Absolutely matters. Then the beauty of it is you let the calculator clean this mess up. Get comfortable with ugly fractions. This question, the answer is always really ugly fractions. Every time. So you go to your calculator and you would type 2 times 3/5 times -4/5. And you would leave your answer as a fraction, and that's it. Two parentheses. These aren't too bad. Good God. Like sometimes it's like -117 over 65 or something. All right, so -24 over 25 is our answer. Alright, now we're going to repeat. With cosine of a double angle, we do have freedom of choice here. Does not matter which one you pick. In fact, I'll work two to show you it doesn't matter. The cosine of the double angle, y'all know me, I just went with the very first one. Read to me another one. Okay. 2 sine squared? 2 sine. Okay. Alright, so the nice thing about this problem is when you find the very first one, if it involves sine or cosine of theta, those exact same fractions, if sine or cosine of theta comes up again, they just get repeated. Okay? So right here, this says cosine squared of theta. Well, what is cosine theta? Negative 4 over 5. So I'm going to replace this with negative 4 over 5, and it's squared. Don't forget that part. What's sine? This, and it's squared. I'm going to go ahead and come over here, and I'm doing the alternative one. Just to show it doesn't matter. You don't have to put 2 on your paper, I'm just showing you. Guys, when is our prom? May 6th? She's good at 3, it's May 6th. Alright, and then now you go to your calculator and you let the calculator clean this mess up. You type it exactly how you see it. Did you get 7 over 25? No, because we're not evaluating trig functions. We're
I did all the parentheses and I have
Is that the same calculator you had yesterday? Alright, look at this. Alright, so what was it? 7 over 25? Let's see how far I can get with tangent. This was just to prove to you that it's, I'm going to put a check there because it's the same thing. Doesn't matter which one you use, you should get the same answer. Alright, tan of the double angle only has one formula, although it's ugly. 2 tan theta over 1 minus tan squared theta. Now be careful here. I'd hate for you to get this wrong for using the wrong fraction when if you look at the directions, they're giving you tan theta. So, you know, whenever you start this problem, they are giving you one of the 3 trig values. So use it instead of going over there and asking yourself, what's tan? Possibly getting your negative wrong. As long as it's negative, it doesn't matter where the negative is in terms of the fraction itself. It matters in the picture. Alright, so tan of theta is negative 3 over 4. So everywhere in here where there's tan theta, I'm going to replace that with negative 3/4. And then of course on the bottom, be careful that is squared. Once again, the negative in the fraction does not matter when you're plugging it into the formula here. It matters that you have the negative, if it is negative. When the negative does matter is when you're drawing your picture and then you're pulling sine or cosine. That's when negative matters. Alright, so now you have to carefully type this in your calculator, and you should get negative 24/7. And we'll pick up on me tomorrow. I'll show you how to type it into the video. Yeah.
Yeah, push the 6.
Alright, hold on. If you don't want to type the fraction in using the fraction shortcut, you can type fractions in by simply putting it in parentheses and doing top number divide bottom number. You'll still get the same answer.